In today's lesson, we will be covering the topic of the trigonometric unit circle, or the trig identities. So first things first, let's go over the basic trigonometric identities and how they relate to a triangle. Trigonometry is all about the study of a right triangle and its unique properties. So as a reminder, a right triangle is simply a triangle with one of its three interior angles equal to 90. So we're going to study how the angle relates to the side lengths of this triangle. So let's pick this angle here, and we're going to name it theta. So the definition of the function sine of theta, it's just a function. You're applying it to this angle, and the results will be equal to the side length opposite divided by the side length of the hypotenuse. Now, something to keep in mind here is the definition of what is the opposite side and what is the adjacent side will depend on the angle you pick. So for example, let's say our theta was up here. If this was theta, then now this side becomes the adjacent and this side becomes the opposite. Opposite being the farthest side length you can get from the angle of interest. The hypotenuse, on the other hand, will never change. We know from Pythagorean theorem, a squared plus b squared is equal to c squared, that our hypotenuse is our longest angle, our longest side length, and therefore will never change when we're picking an angle of interest. So cousin to the sine function is the cosine function. Cosine of theta is equal to the adjacent side length divided by the hypotenuse side length. And then last but not least, we have the tangent or tan function, which is the opposite side length divided by the adjacent side length. I know that's a lot to take in, so there's a really popular monomer or sound way to remember this, and you'll hear people pronounce it as so-ka-toa. And that's short for sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So ka, toa. These three little words will help you out if you're struggling to remember it. And remember who goes in the numerator and who goes in the denominator. And what's cool about the trig functions is they're a lot like numbers and other functions in the fact that they have an inverse. And specifically, I'm talking about a multiplicative inverse. And just a quick reminder, that just means one number, an original number, multiplied by this special number will result in 1. So as a quick example, let's just think of the number 2. 2 times 2 to the power of negative 1, which is the same thing as 2 times 1/2 is equal to 1. In this case, 2 to the power of negative 1, or 1/2, is the multiplicative inverse of 2. 2 times 1/2 will give us 1. So our trig functions also have inverse identities. So first off is cosecant, which is the inverse of sine, 1 over sine. And when we're doing our inverses, it's just like the 2. You're switching the numerator and the denominator. So cosecant is calculated as the hypotenuse divided by the opposite. The inverse of the sine function is called secant. So 1 over cosine means hypotenuse divided by the adjacent side length. And our last inverse function, you can guess it, is a cotangent, or cotan, which is 1 over tangent of theta, or adjacent over opposite. So I know this is a lot. These are a lot of definitions. So for me, what helps is just remember the basic definitions, your so, ka, toa, and when you're doing your inverse, just remember you're swapping your hypotenuse and your adjacent. You're swapping your numerator and your denominator. So easiest thing is just start remembering the basic trig identities, and you can work from there. So let's try and test your knowledge. If you want to pause the video here, now's a good time. See how well you can remember. What are the 6 trigonometric identities? The original 3 and their inverses. All right, let's see how you did. So, awesome job if you got them. If you didn't, that's totally fine. It is really just a matter of practice. It took a long time for me to remember all of these terms. So, sine is equal to of theta, of the angle theta, is equal to the opposite side length divided by the hypotenuse side length. Cosine of theta is equal to the adjacent side length divided by the hypotenuse side length. And tangent of theta is equal to the opposite side length divided by the adjacent side length. And remember, if we change the angle we care about, let's say this was our angle that we care about, now this would be the opposite side length, and this would be the adjacent side length. So let's test it out with some numbers. But first, a little reminder about degrees and radians. So these are both typical measurement of angles. There are 360 degrees in a full circle, or there are 2 pi radians. And a radian is how many times the radius can go around the circle. Fun fact for the definition of pi. So let's say you have an amount in degrees, but you want to convert it into radians, if your calculator is stuck in radians, for example. So we know we're just going to change our units. So we know there are 2 pi radians in a circle. We know there are 360 degrees in a circle. So let's simplify the math a little. Knock out the 2. 360 divided by 2 is equal to 180. And now degrees times pi divided by 180 degrees will get you the angle in radians. And of course the inverse is true. If you have radians, but you really want to care about degrees, you say x radians times 180 degrees divided by pi radians. Knock out the radians, your units have been converted to degrees. So, one of the most common triangles we study is what's called the 30, 60, 90. And that just means your angles are 30 degrees, 60 degrees, and 90 degrees. So that follows the triangle rule of interior angles, so that the total sum of the angles must be equal to 180 degrees. Double check the math. So it's so common, and we're so used to using this, that most people just write these lengths as a ratio. So let's keep it simple. Let's just say x is equal to 1. So for sine of 30 degrees, if I care about 30 degrees, we know it's opposite, 1, divided by hypotenuse, 2. So sine of 30 degrees is 1/2, 0.5. Meanwhile, cosine of 30 degrees is equal to radical 3 divided by 2. So those with their calculators, that's about 0.866, so on. And then we do the same thing with 60 degrees. Now this is our angle of focus. So our cosine, this becomes the adjacent side length now. Cosine becomes 1/2, and sine becomes radical 3 divided by 2. So you see how they swap when we swap if we're going from 30 degrees to 60 degrees. And you'll see that happens a lot when we cover the unit circle here directly. And so last but not least, for our tangent of 30 degrees, we're doing opposite, which is 1, divided by radical 3. As just a small note, if you remember your radicals in the denominator simplification rules, most people don't like radicals in the denominator, so we just multiply it across by radical 3. So it is the exact same number as radical 3 over 3. This is just a common way to write the exact same thing. Depends on what your needs are or how much you need to simplify the answer. And then we have tangent of 60 degrees is going to be radical 3 divided by 1. So on your own, let's see if you can handle this. The 45, 45, 90 triangle. It's much beloved because it's simple. So let's take a moment and pause. And can you calculate the trig identities for this triangle? So what you should be finding is that you end up with sine and cosine both being equal to 1 over radical 2, which again, with our radical simplification, simply becomes radical 2 over 2. Now that number, 0.7071 dot dot dot, it's very common. So you should get used to seeing it and remember right away, that is radical 2 divided by 2. And what's also fun about this, if you think about it, is the tangent of 45 degrees is 1. So let's say x is still equal to 1. 1 divided by 1 is 1. Or if x is equal to 5, 5 divided by 5, still 1. So that's what's kind of fun about a 45, 45, 90 triangle. So we keep alluding to this unit circle, but now let's actually take a look at it, now that we have the basics down for sine and cosine. So I don't want you to get overwhelmed, but all this does, it lists the angles we just talked about. We have 30 degrees, 45 degrees, 60 degrees. And now let's see. The unit circle has a radius of 1, so at the most extreme, its x value is equal to 1. So we say at 0 degrees, cosine is equal to 1, because there is no opposite. If you draw your triangles, you follow the radius and then you go down. So follow the hypotenuse and then go down. So for 30 degrees, we know that we have a larger cosine value because we just did that, right? Cosine of 30 degrees is radical 3 over 2. But sine of 30 degrees is 1/2. So we know we're closer to 1 or a larger number in the x value. That corresponds to your cosine, because cosine deals with the adjacent, this bottom length here, right? Versus sine deals with the vertical line here, or the y value. So same thing, our 45 degrees is that equal point where the x distance, the cosine value, is equal to the y distance, the sine value. And so on to the 60 degrees, where it's a higher sine value. We know we're higher, we're closer to 1 in the y-axis, but the x value is smaller at 1/2. And then at pi halves, sine of pi halves is equal to 1, but sine of pi halves for cosine is equal to 0. And that's because we're at this high point of the circle. And so on and so forth. You keep increasing your degrees, and this is what your answers will be if you plug them into your calculator for sine and cosine. So let's take a moment and think about where cosine and sine would be positive and negative. Well, since sine corresponds to our y values, anything above the x-axis will give us positive sine. So we say from 0 degrees to 180 degrees, from 0 radians to pi radians, sine is positive. See these positive y values. But for cosine, anything to the left of the y-axis, so anything in a negative x range will be negative. So from pi halves to 3 pi halves, from 90 degrees to 270 degrees, the cosine function, the x values, will be negative. So take a moment and pause, think to yourself, where would the tangent values be positive and negative in this unit circle? What quadrants would that correspond to? All right, let's see. Since tangent is equal to opposite over adjacent, if both values were positive, tangent would be positive, or if both values were negative, tangent would be positive. So tangent is positive in this region when both the sine and cosine values, the x and y values, is positive, and tangent is positive in this region when both values are negative. Tangent will be negative when one is negative and the other is positive. So tangent is negative in this quadrant and in this quadrant. So to try it on your own, let's talk about how to make a unit circle. So first off, draw that circle with a radius of 1, all the way around. And next, let's just pick a point that you're studying. Let's say right here, P of x comma y. So you draw the line from that point on the circumference back down to the center. Now we know because the radius is 1, this hypotenuse, this distance must be equal to 1. So that'll help us out here for the math, right? And then now we know the angle, when we're sweeping the angle from the positive x-axis, that's going to be our theta that we study. You should not take this theta, because that might swap your x and y values, because you'll get it's a smaller theta, right? So you'll be getting both a positive x and y. Sine and cosine would be positive, when that's not true. We know because this is to the left of the y-axis, this x value should be negative. And that's because our angle is bigger than 90 degrees. See, it goes all the way over here. So we know cosine of this theta will be a negative number, but cosine of this theta must be, but sine of theta will be a positive number because we are between 0 degrees and 180 degrees. So I encourage you to draw some unit circles on your own, pick some points, measure the angle with a compass, for example, and try out some trig values on your own. It takes a bit of practice, but it's going to be very helpful for your future geometry studies. Thank you.